Okay, this is the 2.2 video lesson for geometry, conditional statements. The learning target here is to recognize conditional statements and their parts, and then to write converses, inverses, and contrapositives of conditionals. So, conditional statements is basically just an if-then statement. So, if something, then something. And symbols used for the conditional statement is P and then an arrow to Q. And so the part of the conditional that is after the if statement is called a hypothesis. That's the P part. So if P, then Q. Q is the conclusion. It's the part that's after the then. Okay, so symbols is P, arrow to Q. This means if P, then Q. And it could also say P implies Q. And then here's a Venn diagram of this, right? This just means P is part of Q, right? So if you know that P is true, it's already inside of Q, so Q has to be true too. Okay, let's see how this works. So the first thing that we're going to do is identify the hypothesis and conclusion. Remember, the hypothesis is the part of the conditional that is right after the if state part of the statement. So when this is asking for the hypothesis, let's look for that first. It's basically don't include the word if, and then everything after that up to the comma. That's my hypothesis. Okay, and then the conclusion is the then part. Don't use the word then, but everything else after. So the hypothesis is an animal is a robin. The conclusion is the animal is a bird. Okay, so try this next one after pressing pause and then check back for your solution. Okay, so the hypothesis was just an angle measures 130 degrees or 130, and then the conclusion is the angle is obtuse. So just make sure you don't include the if or the then. The hypothesis is the part after the if, the conclusion is the part after the then. Okay, so now we're moving on to writing a conditional. So how can you write the following statement as a conditional? So vertical angles share a vertex. So if we want to write this as a conditional, let's think about how to, and make sure you're saying it correctly, make sure your sentence makes sense, right? Where this is going to be, since we're looking for a conditional statement, we want an if-then statement. So if, then. Okay, vertical angles share a vertex. So if angles share a vertex, then they are vertical angles. Now, is this true? This is not true, right? Angles can share a vertex and not be vertical angles, right? They can be like this. So that is not the actual statement. That makes sense, right? So be careful with these. Vertical angles share a vertex. So this is not actually this is not writing the same statement. So maybe if we switch our hypothesis and our conclusion, it will make sense. Okay, let's try this again. So let's just switch these. If two angles are vertical, then they share a vertex. And that makes sense, right? So be careful with these. Make sure you reread it and it makes sense in the problem, and that's still true. Okay, so this is saying because vertical angles share a vertex. So if we have things that share a vertex, right, vertical angles are in here. Vertex, right? So before when I was saying if they share a vertex, right, that was this big circle, right, all the things that share a vertex. And this is saying then it has to be vertical angle, but that's not true, right? It could be something that's not a vertical angle that shares a vertex. But here, this vertical angles are within the sharing vertex circle, right? So if two angles are vertical, then they share a vertex. So they're already inside there. Okay, so try this one on your own. Dolphins are mammals. Write it as an if-then statement, and then reread it, make sure it makes sense and it's true. If not, maybe try switching your hypothesis and your conclusion until you get one that works right. Okay, so press pause, try this on your own, and then check back for the solution. Okay, so this one is, if an animal is a dolphin, then it's a mammal. So I know what this just says, dolphins are mammals, right? You could also, the way to approach this, right? We have two different things, dolphins, mammals. So it's either going to be if dolphin, then mammal, or if mammal, then dolphin, right? So this is how you can approach these to make sure, well, if it's a mammal, it doesn't have to be a dolphin. So this one's not true. And so this one has to be true. If it, for this to, if, assuming this is true, we're going to assume this is true. If it's a dolphin, then it's a mammal, right? If dolphin, then mammal. And this isn't an actual correct English statement. So we're just going to have to modify this to put in words to make it make sense. So that's why I added, if an animal is a dolphin, then it's a mammal. Okay? Okay, and we were talking about these two statements here were true. And so are our conditionals. And so we're going to talk about the truth value of a conditional. So the truth value of a conditional is true or false, right? You can have a conditional that's wrong, right? This was still a conditional, even though it said if angles share a vertex, then they are vertical angles. This one just happened to be false. Its truth value is false. This one was true, right? This one was true, and this one was false. Okay, so now we're going to talk about the truth value. So let's look and see what these are. Are these conditionals true or false? If a woman is Hungarian, then she is European. This does require that you know that if someone is Hungarian, they are from the country of Hungary, and it is true that Hungary is in Europe. So if a woman is Hungarian, then she is European. So this one's true, and that's because Hungary is in Europe. Okay, and then for this next one, if a number is a multiple of 3, then it is odd. This one is false. And we know it's false because we just have to think of a multiple of 3 that's not odd, right? What about 3 times 2? That's 6. So 6 is not odd, right? So, and this is called a counterexample. I think we get to this on the next page, but so this is false, and I've given a counterexample to prove that it's false. Okay, so these are for you to try on your own. So press pause and then check back for your solution. Okay, so the first one was false. It's a little bit tricky. It does not say if a month has only 28 days, right? Otherwise, if it did say it has only 28 days, then it would have to be February. But this just says if a month has 28 days. Well, that's false, and my counterexample is January, right? January also has 28 days. It does have 3 more days, but it does at least have 28 days. So that one's false. And then if 2 angles form a linear pair, then they are supplementary, which is true because all linear pairs are supplementary. Okay, moving on to another vocabulary word. The negation of a statement, P, is the opposite of the statement. It's basically just putting the word not in front of the statement, right? So, and this comes in handy when we are talking about conditionals, and then converse of that conditional, an inverse of that conditional, and a contrapositive of that conditional. So we have our conditional. It's an if-then statement, and our symbol is P, if P, then Q, right? Okay, and here's an example. If I live in San Francisco, then I live in California. Okay, is this true or false? Let's write the truth value of this. Well, San Francisco is in California, so if you live in San Francisco, then you also live in California, so true. Now, a converse of a conditional is just switching the P and the Q. Just switch turn your conclusion into your hypothesis and your hypothesis into your conclusion. And then we're going to see if that new statement is true. So let's use this if I live in San Francisco, then I live in California example, right? This is my P, my hypothesis, and this is my Q. And now we're going to switch them so that this is going to be if. And now I'm going to write the Q first. If I live in California, then, and now I'm going to write the Q, the hypothesis now as the conclusion, I live in San Francisco. Okay, so this is the converse of this statement here. I just switched the P and the Q, but I kept the if and the then there where they were. Okay, now is this true? If I live in California, then I live in San Francisco? Well, we live in California and we don't live in San Francisco, right? So this is false. And we can say a counterexample would be just we live in Salinas. Okay, so an inverse now is going to be, you're going to have the P and the Q in the same spots. Right now you're going to negate each of those statements. So remember, negate means not P, and it's this little squiggly line in front. That's the symbol for that. So our P was I live in San Francisco. The negation of that is I do not live in San Francisco. So let's write the inverse of this. If, and now we're going to write the P, but we're going to write the negation of P. If I don't live in San Francisco, I didn't write the word live. If I don't live in San Francisco, then, and then I'm going to write the negation of my Q. I don't live in San Francisco. And then we need to figure out, is this true or not? Well, we don't live in San Francisco, right? Oops, I wrote that wrong. California. Here, sorry. You guys probably saw that. Okay, let's fix this. Yeah, if I don't live in San Francisco, then I don't live in California. Well, we don't live in San Francisco, right? But we do live in California. So this is false. And we can use the same counterexample, which is Salinas. We could live in Salinas, and then we would not be living in San Francisco, but we would still be living in California. So that's false. Okay, and then now the contrapositive, as you would expect, now negates our P's and our Q's, and then also switches. So this just switches. This does not switch. It negates. And then this switches and negates. Okay, and that's the contrapositive. So you can see, right, this is switch if and then parts. This is just keep the if and then from the original conditional and make them not, and then contrapositive is you switch them and make them not. So let's put our Q first, but our not Q, if not Q. So if I don't live in California, then I don't live in San Francisco. Okay, so we've taken our conditional, we've switched the P and the Q, and we've negated it, both of them. And that's called a contrapositive. So if I don't live in California, then I don't live in San Francisco. Is this true or false? This is true, because if you don't live in California, because San Francisco is in California, if you don't live in California, you can't live in San Francisco. This is true. Okay. On the next page, I'm going to leave it here because we need this to answer the next question. The next question asks, which pair of statements have the same truth value? And you can see here that is the converse and the inverse are both false, and the conditional and the contrapositive are both true. And these pairs are, they're called equivalent statements. So you're basically saying the same thing in the conditional as you are in the contrapositive. If you say, I live in San Francisco, then I live in California, it's the same as saying, if I don't live in California, then I don't live in San Francisco. And the converse and the inverse are two ways of saying the same thing too. So your truth value of your converse and your inverse will always be the same, since they're equivalent statements. And your truth value for your conditional and your contrapositive will always be the same. So that's a good check when you're doing these, when you're doing the truth value. If you get true here and false here, something's wrong, right, for your converse and your inverse, and same with conditional and contrapositive. Okay, so here is where it asks, which pair of statements have the same truth value? We have the conditional and the contrapositive. And then we also have the inverse and converse. And these are called equivalent statements. Okay, so moving on. This next question is asking us to write and find truth values of statements. So what are the converse, inverse, and contrapositive of the following conditional? What are the truth values of it? And if false, give a counterexample. Okay, so this is one for, I guess, let me see, hold on. Okay, I was going to say that this was one for you to do on your own, but we'll do this one again together, even though we just did another one together, and then you'll have one to do on your own after this. Okay, so we have a conditional. Now we need to write, and this is the way that maybe the question would be asked on a test. What are the converse? So this is my conditional. Let's figure out if it's true or not, right? We need to know the truth value of that. If a figure is a square, then the figure has four sides. Well, in the definition of a square, right, then it has to have four sides. So this is true. Okay, so now what is the converse of that? So the converse, and make sure you write that this is the converse and label it, right? Remember, this is my P, and this is my Q. So my original conditional is going to be if P, then, oh, I used the wrong color. Then Q. Okay, so the converse is going to be if Q, then P. So let's just rewrite this. with our symbols here. If, and I'll push pause, you don't have to watch me write. Okay, if the figure has 4 sides, then it is a square. You can see all we did was just switch these, right? Okay, is this true? If the figure has 4 sides, then it is a square? Well, not all figures that have 4 sides are squares, right? A quadrilateral is the name of figures that have 4 sides. And so let's use a rectangle as our example, as our counter example, false. What about rectangle? Okay, this was my converse. I know I wrote it there in green, but let's write it again. Okay, now let's move on to inverse. Okay, and we're going to keep the P and the Q in the right order. This is just going to be not P. If not P, then not Q. Okay, so we're going to just rewrite the same as the conditional, just throw in some knots. Okay? Okay, so I just rewrote the first conditional and just added in the words not, right? If the figure is not a square, then it does not have 4 sides. Okay, so that's my inverse. Is this true? Because we know these are equivalent statements, we know the truth value here is false, and we can use the same counterexample because they're equivalent statements. So this is going to be false, and we can also say rectangle. And then let's actually think about it, make sure it makes sense so we can catch any mistakes we made. If the figure is not a square, it's a rectangle, then it does not have 4 sides. Now, if it's a rectangle, it does have 4 sides, so that's our counterexample, and it works. Okay, and then the last one is going to be the contrapositive, and we're going to switch the Q and the P and then negate them both. Okay. Okay, so we have switched it, negated them. If the figure does not have 4 sides, then it is not a square. Because this is equivalent statement to the original conditional, which was true, this one has to be true as well if we did it right. So let's write our truth value is true, and then let's think about it. If a figure does not have 4 sides, it's not a square. No, because squares have to have 4 sides, right? So this is true. Okay, so one last one for you to try on your own. If a vegetable is a carrot, then it contains beta-carotene. And you probably need to know that carrots do have beta-carotene to decide if this is true or not. So let me start by telling you that this is true. And also, you probably need to know that other things have beta-carotene, not just carrots. So with those two notes, please try this on your own. Write the converse, the inverse, and the contrapositive, and then give its truth value. And if it's false, give a counterexample. So you may need to Google what other vegetables have beta-carotene in it, because that's what I'm going to do after I press pause. So press pause, try these on your own, and then check back for the solution. Okay, here you have it. Hopefully you wrote that all out before you pressed play again. Yeah, just switch these. This is false, and if you Googled what other vegetables have beta-carotene, maybe you picked broccoli as your counterexample. And then when you did your inverse, you could use the same truth value, and you just have to add the knots. Make sure you leave the same order as the conditional for the inverse. So yellow, blue, 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 yellow, but then not and knots. Okay? That's it. Enjoy.